Swayam Prabha. Digital India. Educated India.
Demonstration on VECA. VECA stands for Vaikato Environment for Knowledge Analysis, and it is a collection of machine learning algorithms for data mining. It is an open source software developed at the University of Waikato, New Zealand. So, you can get more details about VECA and different machine learning techniques and how to prepare the input files and how to interpret the results in this book, right, written by Ian Witten, and you can also look at the website for more information. So, in this demonstration we will explain how to develop a prediction model, for example, to discriminate two different sets of proteins, in this case alpha helical and beta strand transmembrane proteins. So, we have to follow different steps for the discrimination. First, we have to prepare data set, right. In this case, we have to get the sequences for the transmembrane proteins, both alpha helical and beta strand proteins, and you classify these into training and test data sets, and from this training data set we need to extract different features as we discussed earlier in the class, like the amino acid composition or different properties, and we use any machine learning algorithm available in VECA, right. There are more than 50 algorithms are available, and you train the model. Then once you train the model, you get the results, and we need to do the validation using the 5-fold cross validation or the sample split and assess the performance. So, we will see the details how to create the data set and how to get the features and how to validate any algorithm with respect to different assessment parameters.
We will begin the exercise by downloading the transmembrane proteins from PDBTM. Go to download files. There are 3 categories: code list, sequence, XML. We need the sequence to extract the features. So, under sequence, download the non-redundant alpha sequence and non-redundant beta sequence. I would suggest you to download the redundant and use CD it to convert it into non-redundant sequence. In this demo, I will save the non-redundant alpha and non-redundant beta sequence as my data set. To extract the features, we will use a simple program. We will calculate composition as the features in this exercise, but you can calculate other features which you think will be useful for your problem. The program does 3 main tasks. First, it reads the FASTA file, that is sequence file which we downloaded, and convert and store in the memory as sequence, and this sequence is converted to composition, which is our feature, and features are converted to ARFFF file, which is the input file for VECA. So, the code is written as follows: read the FASTA sequence, both alpha beta, calculate the features, and I am adding the label as alpha and beta to the data set. Then I am randomly splitting the data set into training and test. 90% of the data will be used as training, and the remaining 10% will be used as test data set. Further, I am writing the split data set training and test to a input file, ARFF file, in the VECA prescribed ARFF format. So, let me execute the program. The program is executed. Let us go to the folder. You will find 2 files, alpha beta test and alpha beta train, which is the file written now. Let's look into the file. This is the ARF format. As you could, the first line starts with at relation, which gives some unique name so that we can refer the file later. I'm written composition. Then there are attributes. Attributes are the features or properties. So alanine composition, which is of type numeric. Attribute can be of two types. One can be the numeric, the other can be nominal categorical variable. For example, the last attribute, which is a class, is a nominal type. We have two categories, alpha comma beta, which is given in the curly bracket. Followed by the list of attribute, we have a section called data at data, where each features are given for each data point in a comma separated format. So I have written all the alpha, that is alpha helical transmembrane protein, and calculate the composition, and I listed line by line, followed by the beta transmembrane proteins. So my entire data set for training is listed in a single file, where each row corresponds to each protein. So this is a format for Weka. Now that we have created the input file for Weka, let's move on to Weka. So Weka is a collection of machine learning algorithm. So it forms a wrapper, a kind of a package, so which facilitates us to access the algorithms easily. So you can download the Weka from the Weka website. Weka supports 3 operating systems, the Windows, Mac and Linux. And since Weka is written in Java, you need a working Java environment to use Weka. You can install Java by downloading the Java VM, or Weka also comes with JRE, which you can download and directly install it. In case you face any problem in using Weka, check your Java environment first. I have already installed Java in my system and Weka. Let me launch Weka. So Weka starts with the logo, is a Weka bird. So as you see, there is a small window which is a Weka GUI. There is a menu bar which has few options to visualize tools and other things. There are 5 main buttons on the main window. That is essential, that the functionalities of the Weka. The first one is the Explorer, which we will be discussing in this tutorial. The next one, Experimenter. Experimenter is used to compare multiple classifiers, algorithms with a different data set for your work. And Knowledge Flow gives a graphical interface to do this. Workbench is a composite of all this, and simple command line interface is a GUI-less Weka access point. So you can access all the Weka's functionality in the command line here. So let's begin. Let's go to Explorer. So the preprocessed tab, click on Open File and open the training input file. The tab is now populated with the data which from the file. As you could see, there is a filter section and there is an attribute section, and there is a statistical section here which displays the attribute information here, and there is a graph. So each attribute can be selected by checking here the checkbox. If you click on the class, you could see that blue, that stands for alpha, and red for beta. The first class is given the blue color. or the count number of proteins in each class is 547 and 91, which is displayed here, and the corresponding weight. So, similarly you can get statistics of all other variable here. If you want to look into much more detail the relation between the attributes, you can go to visualize. As you could see that each feature or the attribute is listed here in x and y axis, and the corresponding relationships are showed here. This is very useful in case you are analyzing your data. For example, if I click on this plot, this is a plot between x, that is the glutamic acid, and y, that is the asparagine. So, you could see the relationship. As you could see, the y axis differentiate the red and blue, which is alpha and beta. So, it could be a potential good feature. Such analysis can be done here for more complicated problems. You can choose and analyze the data. Let us go on to pre-process, and the most important part of the pre-process tab is a filter. You can add filters here. There are a lot of different filters available in Weka. Feel free to explore it. And there is a supervised category and unsupervised category. In supervised category, there is another two categories, attribute and instance. This filters for the attribute will modify the attributes listed in the attributes list, whereas instance will vary or modify the actual input data. So, if you want to edit your data, you can directly go to edit and change, modify, and can save this data, but which should be avoided because this will modify your original file itself. Once you are done modifying, once you are done loading the data, go to classify. Here we will actually train the model in this tab. So, there is three different sections here, as you could see: classifier, text option, which is a validation part, and there is a classifier output where you would see the output. So, 0R is by default is a classifier which is displayed here. Why 0R? We will come back to that later. If you click on choose, you will see a list of classifier here. For example, base. Under this folder, you will see many more classifiers. These are the actual algorithms which is wrapped here in Weka. You can use BaseNet to train a model. Similar algorithms are grouped under single folder. For example, based algorithms are displayed in base folder. Tree based algorithms are displayed in trees folder, and decision rules based algorithms are displayed in rules folder. And there is a separate category called meta. Meta algorithm or kind of classifier which depends on the other classifier. They are modifier classifier, meta classifiers. So, they are listed under separate category under meta. So, you can learn more about this each classifiers by selecting them. You will see the BaseNet is selected here and the parameters are listed here. You can click on that, you can see a tab opened, you can modify the parameters here. If you want to understand what these parameters mean, you can click on more, look at the details. Each parameter and the method is displayed along with a reference. Make sure you understand what the method is before you are using it. And you can see the capabilities, what they are designed to do. For example, this is a binary classifier. It does not do regression, does only classification. So, once you have chosen your classifier or the algorithm, second you choose the validation method. There are 4 different validation methods listed here. Use training set, where you could train your model using the training data set and test its performance on the training set, which may not be useful as a validation procedure. And the second is a separate test set, where you can feed a blind test set or independent test set as a for validation, and third is a cross validation, which I will explain you, and fourth one is a percentage split. In percentage split, for example 70, I will hold 70% of the data for training, and remaining 30% will be used for testing or the validation. Okay, let me run the program. By default, Weka chooses a last attribute as the class. So, in case if your class variable is not the last variable, you have to change it manually. Select the class and click on start. Now the model building is done. The Weka has trained your model and the results are listed here. Each classifier will have a different algorithm, so they will display different information here, but the summary will be the same, which is composed by the Weka interface. As you could see, the correctly classified instance is 185, which is the 30% of the total data, which we used as a test set, and the percentage of the correctly classified is 96.85, which is nothing but accuracy, and incorrectly classified are 6. Similarly, you can see the other details such as the TP rate, which is sensitivity, and FP rate, precision, recall, MCC, ROC, other details are listed here for both alpha and beta. If you consider alpha as positive, TP rate of alpha will be the sensitivity, and TP rate of beta will be the specificity, and the total weighted average will also again be the accuracy. And below you could see the confusion matrix, where it should be read as alpha classified as alpha, A classified as A classified as B. So, A classified as A will be the TP, as you learned in the class. So, you can also calculate the sensitivity, specificity, other parameters from this confusion matrix. Since percentage split divides your data 70 in 30 randomly, so by changing the random seed parameter, you will get different results. For example, normally if I run the algorithm again, you will find the results do not change, because Weka does not change the random seed. In case you want to get different results, go to more option, you will see a field random seed, change it. Now if I run it again, you will see the result change. This is because now different 70 and 30% of the data is taken as training and test. So each time the random variable is changed, different section of the data set will be taken as training and test, and corresponding value will change. In case you are using this for your work, do it more times and get the mean and variance of the each parameter. The other way of validation is a cross validation. For example, in a 10-fold cross validation, the data is split into 10 equal parts, and 9 is used for training and remaining 1 is used for test in first iteration, and this is repeated 10 times. So, from the 10 iteration, every data will be used as training and also test. Cross validation is a better method if you have a limited data and you need to validate. Percentage split is better if you have a large data and you can afford to lose some of the data for testing, because those information won't be available for your model. So, I used cross validation and ran my results. You could see I got a 97% accuracy, which is pretty good. You can also try other methods, other classifiers. Data mining is kind of experimental science. let me choose a meta classifier. There are 4 types of meta classifier. One which does bagging, boosting, and there is a stacking. The other type is randomization classifier. So, stacking simply uses 2 algorithms and stack it one by one. So, input of one will be from the output of the other. So, let us use bagging. So, since I said this is a meta classifier, they depend on other classifier. So, under the properties, choose another classifier from your list. Let me use J48. It's a decision based classifier. It's a tree classifier. I am running the training the model, and here are the results. In our case, we have used all the 20 amino acid composition as attributes, which is very huge. You can reduce the number of attributes because all the attributes won't contribute to your model performance. We can use select attributes for that. Under select attribute, you could see the attribute evaluator, the method, and the search method, which is search algorithm to be used, and the validation method again. I am going to choose one of the evaluator. I am going to choose the classifier attribute evaluator, and the search method is chosen as ranker. I am going to use full training set. Under the classifier attribute evaluator, I am going to change the classifier. Now, the ranker has ranked our attributes based on the importance for the performance. Based on this, you can remove some of the attributes. Let me remove some of the attributes. For example, I am going to reduce cysteine. I am going to run the model again. So, you can use feature selection to improve a model performance. Let me choose 0R now. Why 0R is set as the default classifier in Weka is because 0R works by predicting every data point as the class which is available frequently in your data set. For example, in our data set, alpha occurs 547 times, which is more than beta. So, 0R does, it predicts everything as alpha. As you could see, the sensitivity is 1 and the accuracy is 0.857. So, you should remember that this is a baseline for your performance, and so to evaluate other methods only based on this performance. That's the reason 0 is set as a default classifier in Weka. So, anything which performs less than this may not be useful at all. Okay. So, let us go to our task. Since we have select attribute method, this time I am going to use cross validation, and here I could see many attributes do not contribute to the performance: alanine, glutamic acid, histidine, etc. Now I am going to remove this. I would suggest you to remove one by one, because though these results here show that the attribute does not contribute to the performance, it may have an indirect role. So, remove the attributes one by one and check the performance. Once you are done with the attribute selection and proper validation, let us test our model, selected model with the blind test set. The model performed on the test set is listed here. Sensitivity, accuracy is 98%. If you want to see the individual prediction, go to more option, under output prediction, choose plain text, do OK. The output predicted for each data point is listed here. For example, first data point, the actual class is alpha, the index for alpha is 1, but predicted as beta, index 2. In case of error, there will be a plus sign in this column, and the prediction probability is displayed here. For each data point, the results are displayed here. The prediction probability for some classifier such as BaseNet and logistic regression is calculated in the algorithm, whereas for others it is calculated from the results. So, understand the difference between each classifier and use the Weka wisely. You can save a model by clicking on the save model. Which can be used later for new predictions. Thank you.